Okay, so for chapter 5, one thing that's nice about chapter 5 is that it's kind of the same thing, which is basically factor it and reduce it. And the piece that students struggle with, or basically the only piece that students struggle with, is the factoring portion. So in general, our whole theme is to simplify rational expressions. And then just a reminder that if something is a rational expression, it means you have a fraction, right? That's what a rational expression means. So when you see that word rational, that just means you have a fraction. Okay, so that's the part that we need to make sure that we're paying attention to. And so for us, we're going to have a polynomial over a polynomial. So we're not going to have just numbers like 3 over 4 or 6 over 8. We're going to have variables. So the piece that we need to make sure that we pay attention to is that when we are simplifying a rational expression, it's because our numerator and our denominator is fully reduced, that they have no common factors, right? So if they have a common factor, then we should be able to reduce them. So if they have both a numerator and a denominator have, say, x minus 2, then that means we need to reduce that down, okay? So the other piece that we have to be able to do is we have to find excluded values, okay? So we have to be able to find excluded values. Okay, so when we do our excluded values, it's where our fraction is undefined, and we know something is undefined if we're dividing by 0, right? So for our excluded values, we don't want zeros in the denominator. Good morning. Thank you. Okay, so no 0 in the denominator. And so that's going to be a little bit tricky for some of the problems, but for the most part, it's something we can just do in our heads, okay? All right, so we have to do two things, simplify it and then state the excluded values. Okay, so the steps for us to be able to simplify any rational expression is we need to completely factor the numerator and the denominator. So that might be through GCF factoring, it might be through trinomial factoring, it might be through difference of squares. So we're just going to do off to the side here just a little reminder of what each of those looks like. So I'm going to do over here, say I have 3x plus 12. Okay, so 3x plus 12. Let me zoom in just a little bit. Okay, so this would be what GCF factoring style questions look like. Okay, so Kevin, when we look at this problem here, what do these have in common? A 3. So we're going to factor the 3 out. And then when I divide this by 3, what will I have left? And this by 3? Positive or negative? Positive. Good job. So that's what GCF factoring looks like, right? If they have something common, we can divide it out. And then don't forget to put that in front, right? And then we also have trinomial factoring. And so that's usually when there's an x squared, right? So I'm going to make up one here. And I'm squeezing this in tight. I should have given a little bit more room there, but we'll make it work. So trinomial factoring looks like that. So tri meaning 3, so there's 3 terms. And so this is when we have to do our guess and check, right? I'm going to do it below, and I'll do the difference of squares down here. Okay. So for our trinomial factoring, we're trying to figure out what are our factors of 12, right? So when we think of our factors of 12, we know 1 and 12, 2 and 6, 3 and 4, and I think that's everything, right? So Hayden, when I look at those pairs, which are the pairs that look promising to work with? Why 3 and 4? Because they both add up to 7, right? We're trying to get that 7x. So then what are my factors going to be here then? I'm sorry, what?
X plus 3, x plus 4.
Okay, thank you. Thought that's what you said. Okay, and so then that would be our trinomial factoring. Okay, and then finally our difference of squares looks very different, right? That's something more like this. So if we have x squared minus 25. So difference meaning a subtraction problem. Squares meaning they're both perfect squares. Okay, so for x squared minus 25, so Haley, what would that factor to? Good. So one has to be positive, one has to be negative, because we need that 10x or 5x or whatever in the middle here to cancel, okay? So then that would give us our factor. So that's just a super quick factor review, but that's what we need to be able to do in order to do these problems pretty simply for us, okay? So step 1, completely factor the numerator, completely factor the denominator. Okay, so that's what we're going to do. We're going to factor these. Okay, so Giselle, you're going to help me with the numerator here. So for 4x minus 8, is that going to be GCF, trinomial, or difference of squares? GCF. Okay, so what can I pull out of both of those? And when I do that, what will I get? Okay, good. Okay, so now for the denominator, so Michael, are we doing GCF, trinomial, or difference of squares? Trinomial. Okay, and then just on the side here, I'll write the factors down. And I know most of you just do this in your head, but just for the sake of notes, I'm going to write it down on this first one. So for 16, we can use 1 and 16, 2 and 8, 4 and 4. So which one of these looks promising to get that 6? The 2 and 8. Okay, good. And then what about my positives and negatives, Michael? If I want. Okay, good, right? Because that will give me the positive 6, okay? So there's step 1. So now step 1 is just doing the factoring, and that's really the hardest step. Step 2, determining the excluded values, is not a hard step, but it's the one people forget to do, okay? So we have to determine the excluded values. In order to do that, we have to set our denominator equal to 0, okay? We have to set our denominator equal to 0. So if I look right here, this is like what we did in the last chapter where we have to solve this, right? So I'm going to just do that right here. So I'm going to just say my excluded values. So I have this factored. Okay, and I'm giving myself a little bit of room right here because my answers, I'm going to have an answer there as well, okay? So don't write it tight to the problem. So give yourself a little bit of space here to have another answer, okay? So excluded values. So I set the denominator equal to 0. So it's factored, right? So I just have to do x minus 2 equals 0, x plus 8 equals 0. And most of us can do this in our heads. I'm just writing it down for the sake of notes, okay? All right, so Jaden, what do I need to do to solve this? The packets are up on the cart there. So I didn't realize you didn't grab one. Okay. All right, so I would add the 2 over.
And then subtract the 8.
Okay, good. Okay, so excluded values meaning x cannot equal 2, x cannot equal negative 8. So that's one part of my answer. So if I were to use a 2 and I put a 2 in for here, that would give me a 0. And I can't divide by 0, right? That's an undefined value. If I were to use negative 8 and plug it into here, I would get a 0 in the denominator, and I can't divide by 0. So these are excluded values. Okay, so that's number 2, so that's part of my answer. And then step 3 is we divide out any common factor. So I know that if I have like divided by like, that always reduces to 1, right? So if I have same over same, oops, switched my words partway through. So like over like, that always reduces to 1. 5 over 5 is 1, 10 divided by 10 is 1, x divided by x is 1, right? Okay, so Ricky, when I look at this, what are my like factors or common factors? X minus 2, right? And so x minus 2 divided by x minus 2 would just be 1, so that reduces to 1. So then my answer is 4 over x plus 8. And that's it, right? That's the last step. There's not a 4th step which says keep reducing, right? There's not another step that says to keep reducing. So a common mistake that students will make is they'll try to divide a 4 out of both of these. But I can't do that because there's not a 4 on the x. And if there were a 4 on the x, we would have already factored it out up here. Okay? So we have to be careful. All right, so that is question number 1. Okay. Okay, we're going to do one more together. Okay. So which one of these on 2 through 6 looks very different from everything that we've done? So 3, okay, looks a little different, but I wouldn't say very different. 5, does 5 look very different? Why does 5 look very different?
Because they both have, or one's squared and the other one's cubed.
Do we have to factor this one?
They both have the same value.
We don't have to factor this one, do we? Do we have to factor this one? Yeah, what can we pull out of the bottom? We can pull a 5 out. Do I have to factor this one? Yeah, because what can I pull out of the top? 2x. Do I have to factor this one? Yes. Do I have to factor this one? Yes. What can I pull out of the bottom? A 4. So I'm going to put an F by each of these because I have to factor them before I can reduce them. I have to factor them because there's an addition or a subtraction somewhere in the problem. So if there is an addition or a subtraction anywhere in the problem, that means I have to factor it before I can reduce it. So number 5 does not have a plus, does not have a minus anywhere. I don't have to factor it. I just need to reduce it. And this we've done, right? We did this in the last chapter when we were reducing our division square root problems. So this we already know how to do. Okay, so we're going to do this one anyway, so together. So let's see, Yusuf, why don't you help me with this one? So what divides into 7 and 21?
3.
That's the answer. What divides into both?
Oh, by 7.
I can divide by 7. There we go. And then when I divide by 7, I'll get 3 over 1,
Yeah.
right?
Which is 3.
Which is 3,
Yeah.
okay? And what about my variables? I have a squared, and then I have a
So
cubed.
it's just A.
Where does the a go?
On the bottom.
Why does it go on the bottom? Because there's more down here, right? Okay. So not that we have to do this step, but I'm going to show you just for, again for the sake of notes. A squared means I have 2 of them. A cubed means I have 3. So like factors, and these are factors, cancel to 1. So that's 1 and that's 1. And so I'm left with an a in the denominator. So it would be 3 over 1a or 3 over a. Okay? All right, so a common error, so there's lots of common errors here, is 1, we already talked about this, is you don't factor when you should, right? How do you know to factor? If you see adding and subtracting, okay? The second common error is that people will forget to do the excluded values, or when they do the excluded values, they'll do it after they simplify. So you need to make sure that you find your zeros of the original, denominator. Right? Don't make the mistake of simplifying first. Make sure you find the zeros of the original denominator. Yeah. So how do you find the excluded values? Okay, so we haven't done this one yet, right? So we find the excluded values by after we factor, we set our denominator equal to 0. Okay. All right. So I didn't do it on 5, right? So I need to find the excluded values. Do I do it on the simplified form or do I do it on the original? The original. Okay. So let's do the excluded. I'm just going to use EXE for that. So I set my denominator. So that's 7a to the 3rd equals 0. Okay. So I have to get rid of the 7. I'm going to divide by 7. And then what's a to the 3rd, or what's 0 divided by 7? That's just 0. Okay. So what number to the 3rd power gives me 0? Just 0. So what's my excluded value? A cannot equal 0. Okay. All right, I want you guys to try number 3 before we do 3 together. So you guys try that one for me. So you guys do number 3.